Hello and welcome to Filling the Sink, a podcast from Catalan News. My name is Lucía Benavides, and today we're talking about Catalan biochemist Joan Oró and his groundbreaking research on the origin of life. This month marks what would have been Joan Oró's 100th birthday. And to celebrate, we're going to take a trip back through his life to learn about his work with NASA, his contribution to science organizations in Catalonia, and his research into the possibility of life on other planets. I'd also like to mention that this is Filling the Sink's 150th episode, so congratulations are in order for the Catalan News team on that milestone as well. Joining me today is reporter Cillian Shields. Hi, Cillian.
Bon dia, Lucía. How's it going?
And we have a special guest with us, an expert on Joan Oró. His name is also Joan Anton Catalan. He's a science writer and educator. Welcome. Thank you for being here.
Thank you for inviting me.
Before we really delve into the fascinating life of Joan Oró, let's backtrack a little bit and start at the beginning. Who was Joan Oró? Why is he important? For many, it may be the first time they're even hearing his name. Catalan news reporter Lucía Benavides did a little digging into his life and achievements. Let's see what she found.
Joan Oró was born on October 26, 1923 in Lleida, a city in the western part of Catalonia. His family owned a bakery which he was expected to take over, but Oró had other plans. From a young age, he showed interest in science and the origin of life.
Em va venir una inspiració que em lliurava de la meva rebel·lió contra la
I thought, now I know what I want to do, Oró explained when talking to the Fundació Jaume Font in 1996 via Catalonia's National Archive. I will study the origin of life since neither the Marist brothers nor astronomer Flammarion nor Darwin have explained it in their teachings.
Ni Darwin m'ho havien aclarit.
In the early years of Francisco Franco's dictatorship, he went to Barcelona to study chemistry at the University of Barcelona. He graduated in 1947 but emigrated to the United States in 1952 to pursue his dream of studying biochemistry, something that was impossible both in Franco's Spain and in post-war Europe. In the US, he learned English and earned his PhD in biochemistry at Baylor College of Medicine in Houston in 1956 and started working at the University of Houston. 1959 was the year that changed everything for Oró, who in the United States was known as John. While working at the University of Houston, he discovered the abiotic synthesis of adenine, one of the integral components of DNA. This groundbreaking investigation made him famous. Essentially, he had unearthed a key puzzle into understanding the creation of life. And in 1963, he began collaborating with NASA on a number of significant projects, including the Apollo 11 mission to the Moon and the Viking mission that went to Mars. Oró moved back to Catalonia for a brief period in 1980, where he got involved in politics and became a member of the Catalan parliament during Spain's transition to democracy. But he quickly returned to Houston, realizing he wouldn't be able to do quality research in Catalonia at the time. It wasn't until 1994 that he retired from academia and moved to Catalonia for good, where he lived until his passing in 2004.
Thank you for that, Lucía. So one of the things we just learned is that Joan Oró grew up in Spain during Franco's regime. He was born just 13 years before the start of the Civil War. Joan Anton, can you tell me, what was Oró like as a child?
He was very curious. In fact, he raised questions very difficult to answer, as, for example, why we are here, what's life, things like that. So nobody could answer those questions, of course, at that time. Even we cannot answer those questions today, most of them. And he was very curious. He was reading things like Darwin book about the evolution of species of life. He was reading Camille Flammarion, who was an astronomer, French astronomer and philosopher. So he was very active, a very active mind. So as nobody could answer the questions, he would be the one who would find the answers. That was his decision when he was very young.
Wow, and how did kind of living under Franco's regime affect, the possibilities that he had to be able to do that?
Europe was the place to go to do science. For example, even the American scientists were coming to Europe. But of course, the Second World War changed the scenario, and Europe was no longer the place to go, and United States was the objective of Joan Oró. But in fact, that was very risky for him. That was a very brave jump to the States because he needed permission to go there. He didn't have economic means to go there. And even he didn't know about the English language. So he had a very, very basic knowledge of English.
Yeah, I can imagine. And how did that jump even happen? How did he get the idea to go to the U.S.? Was it a teacher, a colleague?
No, in fact, that was a thing, an idea in his mind that was cooked when he finished the chemistry career studies. He began working in a bakery. It was a family bakery, so cooking bread. At the same time, he was cooking his ideas in his mind about the future. And he tried to find the opportunity to go to the States. And finally, he decided, with the encouragement of his wife, this is a very important figure during all his life, Francesca Fortesa, Paquita she was called, he wrote more than 50 letters to universities and research centers of the States asking for a grant to go to study there. And he received a lot of answers. And one of those answers coming from the Rice Institute in Houston, gave him a grant to go there to study again chemistry. This was not his objective. He was already a chemist here. He wanted to go to do the PhD in the US, but he saw this thing as the opportunity to jump to the States, to have this grant and go there to study.
Okay, so he had to start over when he moved to the U.S.
More or less, with a very basic knowledge of English. His family was left in Lleida, here in Catalonia, and he was alone there, missing his home, missing his language, his friends, completely alone. It was very difficult at that time. And then he jumped to the medicine school of Baylor because he found an opportunity to do the PhD there. So he quit the Rice Institute and he went to the Baylor School of Medicine, and he succeeded with his PhD in biochemistry, not related to the origin of life, that was his main objective. He would have to wait for that, but a PhD related to biochemistry with the cancer processes, and it was very useful for him in the future.
Very interesting. I think you just mentioned it there a little bit about his work on DNA and the synthesis of adenine. But prior to that, this work on cancer research, what kind of investigation did he do in that field? Yeah,
he was studying the properties of formic acid. It's a very basic organic acid. And these studies about the formic acid was very useful for him in the future when he was an advisor for NASA. And we, as a humankind, were trying to find life on Mars. That was a challenge. I think it's incredible. We even today, we don't know almost anything about life. And in 1976, we were challenging nature and going towards Mars to find life. It was incredible. Wow. And these studies about the formic acid that he had done some years before were very useful for him to advise NASA about the results of these first experiments on Mars, when, in fact, NASA believed that they had discovered life on Mars, and he said, no. This is not life. This is related to the formic acid reaction. This has nothing to do with life.
Wow. Okay. Yeah.
Fascinating. His work with NASA is something, obviously, it's one of the major landmarks of his achievements, his research. And I just wanted to ask as well, how is it that, in the first case, a biochemist is involved in space missions, exploring not only Mars, but also he had a major role in the Apollo missions, the moon program as well. So how is it that a biochemist got involved in this kind of field of work that maybe someone would assume is more physics related rather than biochemistry?
You're right. In fact, NASA, by statutory mandate, has the objective, one of the main objectives of NASA is trying to find life outside the Earth. So the implication of a lot of disciplines is very important to have this comprehensive vision about life outside the Earth, and biochemistry is one of those areas, main fields. So Joan Oró was at that time very famous because of the discovery of the abiotic synthesis of the adenine, as you commented before, that was in 1959, and he suddenly became very, very well known in the scientific arena. And NASA asked him to be an advisor for lunar samples analysis, and then for searching for life on Mars. He was one of the few scientists receiving samples, moon samples from the Apollo 11 and then other Apollos, and analyzing those samples to certify that life was not present on the moon. That was a thing that we knew, but we needed evidences for that, and he provided those evidences. He was advising for a Mars mission. In fact, he was not designing the experiments, but supervising, giving advice about the results of the experiments. And that was the moment in 1976, in July, when NASA had a lot of excitement because they thought that they had discovered life on Mars. Was a huge thing, and NASA scientists prepared that announcement, and in that meeting, Joan Oró raised his hand and said, "Excuse me, I have another explanation for this, let's say positive, it's not life, it's a chemistry reaction, only a chemistry reaction, not related to life."
Wow.
And this was very, very important at that time. Yeah.
So he was able to get to them before they announced it publicly?
You're right. And when they announced both things. So we have two explanations, they said. One is, we think we might have discovered life on Mars based on this and this and this, but Professor Oró thinks that this is not life. This can be explained with a simple chemistry reaction.
I know we're sort of like bouncing back and forth between the future and the past a little bit, but I think we almost glanced over the synthesis of adenine, which is one of the major things that he's well known for. Mm-hmm. But this obviously informed what he knew in that meeting to say, no, it's probably just a chemical reaction, it's not life. Tell us about this. This is one of the key components of DNA. It tells us now so much about what we know of the origins of life. But tell us, what was this discovery? What did it mean? Why is it significant? And what has it led to today?
Okay, so the DNA, it might be the instructions book of an organism, of a person, for example. The DNA says how we are, how we function, how we work. And this is written with only 4 letters. We call that the genetic code. And it's fascinating because every organism on Earth uses the same 4 letters, the same genetic code. It's incredible. It's amazing. And
every organism, not just humans.
No, everyone.
Plants, animals,
bacteria, everyone. Yeah. The same. And then of this genetic code, I said we are using, nature is using only 4 letters to write this very complex book. One of those letters is the adenine. So Joan Oró discovered how an ancient Earth, without the presence of humankind with laboratories, because inside our body we are building every second adenine. It has no secret for us. But before life, how nature managed to create adenine, and he discovered that. He discovered how a very old Earth with the oceans and the atmosphere that was very different from ours now, managed to create this adenine. And the adenine is one of these 4 letters of the DNA, but also is an essential part of our cells, not only inside the DNA, but, for example, the currency, let's say the currency that cells use to pay for energy is made of adenine.
Oh, wow.
So the adenine is essential for every organism on Earth.
And just to get a grasp of the magnitude of this discovery, what was the leading theories at the time before Joan Oró's discovery of the synthesis of adenine? What was the picture like before then, and what did it lead to in a world after that? What was science's understanding of life before and then afterwards?
This is very interesting because we had some centuries thinking of the spontaneous apparition of life. This began to change with Pasteur, and then changed in the beginning of the 20th century with Alexander Oparin. Oparin was a very well-known Soviet at that time scientist who created this thing of if we want to discover how life appeared on Earth, we need to understand the chemistry of life. So it's all is about chemistry, understanding the reactions that took place in this ancient life. So understanding how the Earth was at that time, was very different from ours, and trying to find these old reactions that created the first essential molecules that afterwards nature used to create life. And this inspired Joan Oró, but before Joan Oró inspired Stanley Miller, another great scientist from the American scientists who in 1952 and 53 discovered how nature creates amino acids. And the amino acids is one of these essential blocks of life for every organism on Earth. So we have Oparin saying we need to understand the chemistry, the old chemistry, and we have Stanley Miller and Joan Oró opening new paths for the investigation based on we can simulate in our laboratories the conditions of the old Earth and then playing with chemistry inside our laboratories to see what happens. This is Stanley Miller and Joan Oró.
And this is, obviously we don't know the origins of life. We don't know how it went from day 0 to day 1. But is this potentially in search of that?
Yeah, in fact, they opened those paths, but we still don't have the final answers. And maybe we won't have them never, because we weren't there. So we cannot be 100% sure about the chemical reactions that took place at that time. We can try, to guess, we can try to simulate reactions in our laboratories and say, look, we think we have a possible answer, but maybe we won't be for sure, 100% sure, because we weren't there. We cannot certify that those were, in fact, the chemical reactions used by nature.
Yeah.
It's one of the mysteries of life.
It's incredible. I tell that to young people, encouraging them to investigate and to study those things. I believe that there are few things in science as inspiring as this study about the origin of ourselves.
So you were saying it's very important to be curious, to have scientists, or to encourage kids to, ask questions about the origins of life and anything else regarding science. So I'm assuming Joan Oró also thought that this was a very critical thing to inspire young minds. What did he do after he retired? I understand he came back to Spain and gave back to his community.
When he came back to Catalonia, he tried to change things here. So he created a kind of environment that was very, very useful, that has been very useful to improve investigation and science here in Catalonia. He created, for example, the Fundació Catalana per la Recerca i l'Innovació. This is a foundation, an organism that is working to improve research and scientific careers and interest in young people, not only in young people, but specifically in young people. And he created that organism. Then he wanted to create also an observatory, an astronomical observatory, professional one, but not only professional one, but also a place like a cathedral of the astronomy, open to everyone, open to families. And he pushed this project in Montsec range, it's a mountain range.
In Lleida,
in
right?
Lleida,
From
you're
where
right.
he's from.
You're
Okay.
right.
Yeah.
In the pre-Pyrenees, that we call that region, it's a very pristine region in terms of the quality of the sky, of the night sky. And he also created the Fundació Joan Oró, the organism that carries his name. And they, Fundació Joan Oró, have all the assets. We are talking about letters coming from Carl Sagan or Lyndon Johnson and other, important figures of that time. All the personal diaries of Joan Oró, he was very methodic and he was writing everything down. So we have notes from his student ages, but then also when he was investigating in Houston, working with NASA, etc. And we have all that material,
Wow.
and it's taken care of by the Fundació Joan Oró.
Wow. And so we did mention that this month would be the 100th birthday of Joan Oró, were he alive. So I understand the Generalitat has organized Any Joan Oró, or in English it would be the Joan Oró year.
Yeah.
Can you tell me a little bit about that and your involvement in that?
I was asked to be the curator of the year, so I devised the main objectives of the year, and I taken care of the direction of all the activities during this year. And we have a very big exhibition, for example, with things like samples of the moon, real samples of the moon, all the history of Joan Oró, video pills with experts coming from different parts of the science, explaining things about origin of life or the search of life outside the Earth. And we will be moving that exhibition around Catalonia, and then we want to go abroad with that exhibition, even to the States if we are able to do so. And we are delivering a lot of conferences around Catalonia since January, conferences devoted to everybody about
Great.
things like science, biochemistry, life, space exploration, everything.
Yeah. So it's not just about Joan Oró, but about the things that he studied.
You're right.
As well.
In fact, the four objectives that we have is one, letting people know who Joan Oró was and what he did. This is first objective. Second objective is try to understand why it's important for us to study the origin of life, what it means for us. Third objective is encouraging young people to study science and technology. And fourth objective is celebrating the fortune of life. So realizing how difficult life is and how fortunate we are to be here today.
That all sounds amazing, Joan Anton, and I think it's clear to see from his work, he was such a passionate defender of space programs, missions like that, not only because of the scientific work that it leads to, that it is, but also the social value of the missions as well. He was a passionate defender of learning, of conservation, of peace, and I think these values are reflected in his work as well. Can you tell us a little bit about his outlook on life and how it influenced his legacy, his work?
You're right. He became an advocate for peace based on science, knowledge. In general, in knowledge and science, he thought and he explained that knowledge, science, are basic for our understanding as human beings. And he was very good at explaining things to people, at communicating science. And he used his position as a well-known scientist around the world to advocate for peace, cooperation, humility, and values that are very important today.
Okay, it's time now for Catalan Phrase of the Week. Joan Anton, do you want to help us with this one?
Okay, I will try to do so.
What's one that could be related to Joan Oró, origin of life, space?
The moon? Do you want
Maybe the moon.
For example, the moon està a la lluna de València.
Okay.
Estàs a la lluna de València. It means you are very distracted.
Okay.
It's that, you are in the moon, in Valencian moon. I don't know the origin of the terminology, why it's Valencian moon.
You're at the Valencian moon, the moon of Valencia.
Yeah,
That's what it translates as.
Yeah, you are in the moon of Valencia.
Yeah, that makes sense. Like your mind is elsewhere. You're not
yes,
here.
you're not here. You're distracted.
Okay, so estar a la luna de Valencia. Next time I go to Valencia, I'm gonna see if I
Perceive
the
this
moon.
perceive
different
something.
moon.
Exactly. Okay, well, thank you for that. And that's all we have time for today. Thank you, Cillian, for contributing to our reporting. And thank you, Joan Anton, for joining us.
Thanks for having us.
My pleasure.
And we will be back next Saturday with another episode of Filling the Sink. In the meantime, you can catch us on social media or email us at fillingthesink@acn.cat. On behalf of the entire team here at Catalan News, I'm Lucía Benavides, wishing you a wonderful weekend. Goodbye, ciao, adeu.